All right, let's take a look at our practice test. We want to simplify each. And for the first problem, we're going to be looking at 6x over x plus 1. We're subtracting away 5 over 5x cubed. So the idea here, before we even get started, you would notice that you have a common factor of 5 between the numerator and denominator here. So I'm just going to go ahead and cancel that to make my job a little bit easier. And I'm going to put a 1 up there. You don't need a 1 down there. It's unnecessary. Let me just rewrite this as 6x over. I'm going to put x plus 1 here, and then minus. You're going to go 1 over x cubed. Now, the next thing is if you're adding or subtracting fractions or rational expressions, you have to have a common denominator. So what is the LCD here? What is the least common denominator? We talked about that in the last lesson. Essentially, in this case, we have these guys, x plus 1, I can't really do anything with that. X cubed, I can't do anything with that. So here's just going to be the product of the two denominators because they don't have anything in common. So it's just going to be x cubed times the quantity x plus 1. Okay, so that's my LCD. Let me slide that down so I have enough room to work. Let me put equals here. Now, how do I go about solving this problem? Well, I need to rewrite each rational expression as an equivalent rational expression where this LCD is its denominator. So in other words, I have 6x over, I'm going to wrap this in parentheses, so x plus 1, because we're going to be multiplying. I'm going to multiply this denominator by what I need to make it into the LCD. Well, I have the x plus 1, I just need the x cubed. So I can't just put the x cubed here. Again, to make it legal, I've got to do it to the numerator and denominator. Remember, this is just a complex form of 1. Multiplying by 1 leaves things unchanged. So then I'm going to subtract away, same process over here, 1 over x cubed, times, what am I missing? I'm missing the x plus 1. So I can go x plus 1 here over x plus 1 here. Okay, so let me get rid of this right here. Don't need that anymore. And now we're just going to go through, I'm just going to scroll down a little bit. We're going to go through and just simplify. So 6x times x cubed, the 6 would stay the same. X times x cubed is x to the 4th power. And then this is a little bit tricky. If you have subtraction involved, go ahead and put minus, put a bracket there. Okay, I'm going to close that down in a minute. And then whatever this is, I'm just going to put it in here. 1 times this would just be itself. So this would just be x plus 1, and then close that down. The reason I'm using brackets, or you could use parentheses if you want, basically I want to remind myself that I'm subtracting this whole thing away. The common mistake is just to do this, right? Minus x and then plus 1. That's not what's going on. You need to subtract everything away. So to remind myself to change the sign of each term inside of there, I'm going to put the minus out in front of, again, brackets or parentheses. Down here in the denominator, I can just write the LCD, right? So I have a common denominator now. So I can just say this is x cubed times the quantity x plus 1, and that's done. And now I just need to do some simplifying. So let's go ahead and take this 6x to the 4th power. I'm going to basically change the sign of each term inside the brackets here. So minus x and then minus 1. And then this is over x cubed times the quantity x plus 1. Now, whenever we think about a fraction or a rational expression, we always want to report an answer in the simplified form, right? So we want to factor the numerator and denominator and cancel any common factors. At this point in the course, we haven't talked about how to factor something like 6x to the 4th power minus x minus 1. So you might get stuck at this point and say, well, I don't know if I can simplify this or not. But actually, if you use a little bit of the knowledge we learned when dividing polynomials, you'll basically be good to go. If this guy can be simplified, it means that basically you would be able to factor out an x cubed, or you'd be able to factor out an x plus 1. We know that x cubed is not going to be able to be factored out here because this has an x to the 4th power. This is only x to the 1st power. So I don't have enough, and I don't even have an x here. So this is out of the question. The x plus 1 here, this is something we could check with synthetic division, right? So we could come over here and say, okay, well, if this guy divided by this guy gives me a quotient and then no remainder, well, then I know I could rewrite it, okay, using that quotient times the divisor. So how would I do this with the synthetic division really quickly? Well, remember, you need this to be in standard form, and you need to not be missing any powers on your variables. Here we're missing x cubed and x squared, so I could write 6 as the coefficient for x to the 4th power, 0 as the coefficient for x cubed, 0 as the coefficient for x squared, a negative 1 for the coefficient for x to the 1st power, and then a negative 1 for my constant, okay? So let me put this like this. And then what goes over here? Remember, this guy right here has to be 1x to the power of 1 and then minus k. So this can be rewritten as x minus a negative 1, like this, to match up the format that we need, and we want to grab that negative 1. Okay, so let me put this out here, and let me drop this down here, and just go through and see if you get a remainder. If you do, then this guy is basically good to go. It's simplified. If you don't, meaning your remainder is 0, then you have some additional work to do. So negative 1 times 6 is negative 6. Then 0 plus negative 6 is negative 6. Negative 1 times negative 6 is positive 6. 0 plus 6 is 6. Negative 1 times positive 6 is going to be negative 6. Negative 1 plus negative 6 is negative 7. Lastly, negative 1 times negative 7 is 7. Negative 1 plus 7 is going to be positive 6. So this is your remainder. It's obviously not 0. So this guy is going to be simplified, right? So we have 6x to the 4th power minus x minus 1 over your x cubed times the quantity x plus 1. All right, let's look at problem number 2. So we have 5 over 2x minus 7 plus 6 over 3x minus 5. So for this one, let's go a little bit quicker. For the LCD, we know in this case, 2x minus 7 can't factor that. 3x minus 5 can't factor that. Nothing's in common. So it's going to be the product of the two denominators. Now, instead of doing this, and let me write this out the long way so no one gets confused. So 5 over 2x minus 7. Let me wrap that in parentheses. To get to the LCD as my denominator, I would need to multiply by this other denominator, 3x minus 5, top and bottom. So we know this setup at this point. Let me put plus. We'll have 6 over this 3x minus 5 times, I'm going to multiply by top and bottom the other denominator. So 2x minus 7 over 2x minus 7. Now, do we need to do this each time? No. Because all I'm going to end up doing in the end, my denominator is going to be the LCD. So whatever that is, that's what you're going to write. And then this guy right here needs to multiply by whatever this denominator needs to be the LCD. In this case, it's going to be this other denominator. Then this guy right here, similarly, is going to multiply by whatever this denominator needs to be the LCD. Okay, in this case, it's this denominator here. So to shortcut this, let me erase this real quick. And I'm just going to do this for the rest of the practice test. I'm going to take this 5, and I'm going to multiply by this other denominator, this 3x minus 5. Then plus, I'm going to take this 6, I'm going to multiply by the other denominator, so this 2x minus 7. Okay, then this is going to be over the LCD, which is the quantity 2x minus 7, times the quantity 3x minus 5. Now, if this is confusing to you or you start making mistakes when you're doing it, you can always take the extra step of doing what we did the first time. Okay, so let's come down here to put equals, and we're just going to simplify. So 5 times 3x is going to be 15x, and then minus 5 times 5 is 25, and then plus 6 times 2x is 12x, and then minus 6 times 7 is 42. We'll put this over this common denominator of 2x minus 7 times this 3x minus 5, so these two quantities. And really all we have to do is simplify in the numerator. 15x plus 12x is going to be 27x. And then basically you have negative 25 minus 42, that's minus 67. And this is over. You have your 2x minus 7, this quantity, times the quantity 3x minus 5. You're not going to be able to simplify this because the 27x minus 67, you can't do anything there. 27 is 3 cubed, and 67 is a prime number. So this is our simplified answer. All right, let's look at problem number 3. So we have 6 over x squared minus 3x minus 10, and then minus 6 over 7x squared. So let me slide down here. It doesn't look like I can simplify anything to start. I could pull a 6 out, but let me wait to do that. Let me go ahead and factor this first so we can get things started. This is an x here and an x here. I need two integers whose sum is negative 3 and whose product is negative 10. So let's go ahead and put negative 5 and positive 2. Now between these denominators, there's nothing in common. So my LCD is just going to be the product of the denominators. So the 7x squared times the quantity x plus 2 times the quantity x minus 5. Now I don't need to write this each time, but I'm just making that crystal clear. Now, let me actually get rid of this. I'm going to put equals. Now, what did we do in the last time to make this faster? We took this guy right here and multiplied by what it needed. So in this case, this is the 7x squared. I'm going to go ahead and do that. I'm going to end up factoring that 6 out. But just to make this clear what I'm doing, I'm just going to multiply it like this. Then minus, I'm going to go ahead and put this 6 here times this guy here. So this quantity x squared minus 3x minus 10. And then let me put this over this LCD here. So let me just erase this writing and just slide this up here. Okay. Now, as I was talking about, you could pull the 6 out. Okay. You don't really need that there because it's common to this and this. So you might as well save yourself the trouble because you go through and multiply it and then you'd have to just pull it out. So I'm just going to go ahead and say that 6 is going to be out in front. You would have 7x squared, then minus this x squared minus 3x minus 10. Now, I don't need brackets here, and I didn't use brackets there because you have a minus in front of these parentheses here, okay? So I know that to drop these parentheses, and I'm talking about these inner parentheses here, I need to change the sign of each term inside. So I don't use brackets in this particular case. This is over your 7x squared times the quantity x plus 2 times the quantity x minus 5. Okay, let me slide down a little bit, put equals, and we'll say 6 is out in front. The 7x squared would be there. Then I'm going to change the sign of everything here. So this is minus x squared. This is plus 3x, and this is plus 10. And let me close that down. So before we go any further, 7x squared minus x squared would just be 6x squared. So let's go ahead and write 6x squared here and just tighten this down like this. That way we don't have to worry about it. And I messed that up. So let me put the 6x squared and then plus 3x and then plus 10 like this. And let me put this over. We have 7x squared times the quantity x plus 2 times the quantity x minus 5. Now, at this point, you would check to see if 6x squared plus 3x plus 10 can be factored. And in the interest of time, because this video is going to be pretty long, I'm just going to tell you that it is prime. So we're just going to stop here and say this is our simplified answer. All right, let's look at problem number 4. So we have 5x over 8x minus 7 plus we have 5 over 2x minus 6. So you do have a 5 that's in common. So again, you could pull that out now if you want. I think it's probably better just to wait a little while. We will pull it out. Let me put equals here. What is the LCD? Again, it's going to be the product of the two denominators. There's nothing in common. This actually would factor to 2 times the quantity x minus 3. Again, you could write LCD out, but I think we know how to do it at this point. I'm just going to put 8x minus 7. I'm going to stick this 2 out in front here and then put my x minus 3 here. So just multiplying the two denominators to get my LCD. Okay. So for this guy right here, this 5x, it needs to multiply by this guy right here. Okay. This needs to multiply by this to get to the LCD. So I'm going to put 5x times this quantity 2x minus 6. And then I'm going to put plus, I have this 5 here that's going to multiply by this. So 5 times this quantity 8x minus 7. Now, as I mentioned, you want to pull this 5 out to save yourself some work because otherwise you're going to end up having to factor it back out, right? You're going to multiply and then have to factor it. I mean, you could do that, but it's just extra work, so I don't see the point. So let's go ahead and put equals and come down here. I'm going to pull that 5 out in front. And so inside, x times 2x is going to be 2x squared. Then minus x times 6 is 6x. Then plus, I already pulled the 5 out, so don't worry about that. We're going to have basically just 8x minus 7, because if you pull this out, you really think about it being a 1, and 1 times anything is itself. So go ahead and close this down. We could simplify it before we move on. Negative 6x plus 8x is going to be positive 2x. So you can put plus 2x there like that. And of course, let me slide this down, see if I can get it even. Yeah, that looks all right. Let me see if I can make that better. So minus 7 like this. And then this will be over. You have your 2 times the quantity 8x minus 7 times the quantity x minus 3. So again, this polynomial here, this 2x squared plus 2x minus 7, you can pause the video and check on your own if you can factor it, but you're going to find that it is prime, right? So this is our simplified answer. All right, let's look at problem number 5. So what we have here is 3x over x minus 6 plus 6x over x minus 5. So before you even start, notice that you have a 3x that could be pulled out. I think we'll wait to pull it out just for a moment. So we know the LCD here, this is x minus 6, this is x minus 5. It's just the product of the denominators. So I would take 3x and multiply it by the other denominator. That's what I would need, so x minus 5. Let me clearly make that better. And then plus, I'm going to write 6x as 3x times 2, because I'm going to end up pulling the 3x out. And then this is going to be multiplied by the other denominator, which is x minus 6. That's what I would need there. So let me slide this down a little bit. And then we're just going to write this over our LCD, which is the quantity x minus 6 times the quantity x minus 5. Now, again, I told you I'm going to be pulling out this 3x. Again, if you make the mistake of distributing this in, you're going to have to pull it back out, and it doesn't really make sense to me. So just save yourself the work and do it now. So if I pull out the 3x, let me put that here. Inside the parentheses, first you'd have this x minus 5. So x minus 5. Really, there's nothing there to do anything with, so you don't need parentheses around that. Then plus, if you pull this out, you would have 2 times this quantity here. You can go ahead and multiply it now. 2 times x is going to be 2x. And then minus 2 times 6 is going to be 12. Go ahead and close that down. I know that x plus 2x would be 3x. So let me go ahead and write this as 3x here. And then I also know that negative 5 plus negative 12 is negative 17. So let me write 3x minus 17 like this and close that down. Let me put this over our denominator, which is going to be x minus 6, this quantity, times the quantity x minus 5. So this would be my simplified answer. There's nothing else I can really do. Let's look at problem number 6. So we have 3x plus 1 over x minus 6 plus 8 over 8x plus 32. So this, you should be able to eyeball it and see that you can pull out an 8 there, and then you can cancel between numerator and denominator. So what you'd have here is 3x plus 1 over x minus 6, then plus, this is going to be a 1 up here, over this x minus 4. Again, you don't have to do this, but it just saves you work in the end. So let's come down here. Again, we have a situation where the LCD is just the product of the two denominators. So I'm going to multiply this numerator here, this 3x plus 1, by this denominator here, this x minus 4. Make sure to wrap this in parentheses because you're multiplying these two quantities. Let me go plus. I'm going to take this 1 here and multiply it by this denominator. So just x minus 6, because 1 times anything is just itself. Then put this over. The LCD, which is x minus 6, this quantity, times the quantity x minus 4. Okay, let's come down here. 3x times x is 3x squared. Then we would get 3x times negative 4. That would be minus 12x. And then 1 times x is plus x. You can simplify that now. That would be minus 11x. Let's go ahead and do that. So minus 11x. And then 1 times negative 4 is minus 4. So then you have plus x and minus 6. So basically x plus negative 11x would be negative 10x. And then negative 4 plus negative 6 would be negative 10. So 3x squared minus 10x minus 10. You're not going to be able to factor that. Again, you can pause the video and try it if you want. But this guy is prime. So this is over x minus 6, this quantity, times the quantity x minus 4. Again, nothing else I can do, so this is my answer. Okay, let's look at problem number 7. So we have 7x over x plus 5, plus we have 6 over x plus 9. So let me slide down here a little bit and see what we're working with. So again, it's just going to be the product of the two denominators for the LCD. Can't really pull anything out, can't really simplify. So let's just take 7x and multiply by the quantity x plus 9. So again, this guy needs to multiply by this guy. Then plus, I'm going to take this 6. And what do I need? I need to multiply by this guy, so the quantity x plus 5. Let me move this down a little bit. Put this over. The quantity here, x plus 5, times the quantity here, x plus 9. Okay, so let's see what this is going to be equal to. 7x times x is 7x squared. Then plus 7x times 9 is going to be 63x. Then plus 6 times x is 6x. Then plus 6 times 5 is 30. Let me simplify this now. 63x plus 6x is going to be 69x. So put that there like that. Get rid of this. Put plus 30 there. I'm just going to tell you again in advance that that's not factorable. This is going to be prime. So this would be over x plus 5, this quantity, times the quantity x plus 9. All right, let's look at problem number 8. So we have this 12x over x minus 12. We're subtracting away 11 over 11x plus 11. So with this guy, you can simplify. You could say this is 11 over. Factor out an 11 from the denominator. This would be x plus 1 inside. This would cancel and you'd have 1 over x plus 1. So let's put equals. We'll put 12x over x minus 12, then minus 1 over x plus 1. So let's go 1 over x plus 1. So again, a very easy setup at this point. We know that the LCD would just be the product of the two denominators. So I could multiply 12x by this other denominator. So 12x times, wrap it in parentheses, the quantity x plus 1. Then minus, let me put some brackets here so I don't make a silly sign mistake. This 1 is going to multiply by the other denominator, so x minus 12. We put that there, put this over here, and then we have the product of the two denominators for the LCD. So x minus 12, that quantity times the quantity x plus 1. Okay, let me scroll down here a little bit, put equals. 12x times x is 12x squared. And then I'm going to go plus 12x times 1 is 12x. I'm going to drop the brackets and just change the sign of everything. So this would end up being minus x and then plus 12 like this. So 12x minus x would give me 11x. So let me put 11x here and then plus 12 there. Put that like that. And then this is over. The quantity x minus 12 times the quantity x plus 1. So nothing I can do to factor this in the numerator. Again, you can always pause the video and check. But this guy is going to be prime. So this is our simplified answer. All right, let's look at problem number 9 now. And this one, 9 and 10 are going to be a little bit tricky. So I gave you a bunch of ones that are pretty easy overall, and then the last two are kind of challenging. So let me put equals here. First off, before I do anything, I'm just going to factor everything just to see if anything would simplify. I haven't worked this problem yet. I know it does take a little bit of time, but let me go ahead and just factor this first to see what we're looking at. This would be x and this would be x. I need two integers whose sum is negative 14 and whose product is 33. So that is going to be negative 11 and also negative 3. right? So negative 11 plus negative 3 is negative 14. Negative 11 times negative 3 is positive 33. Okay. Then over this guy right here, I'm going to put an x here and an x here. And then essentially I need what? I need two integers whose sum is negative 6 and whose product is negative 55. So that's going to be negative 11 and a positive 5. So before I do anything, again, I can cancel stuff. You don't have to if you don't want to, but it just makes things so much easier if you work with a simplified rational expression. You have a common factor of x minus 11 that you can get rid of. So now I have x minus 3 over x plus 5. So that's the first step for me. So then minus. Over here I have this 5. And then from the denominator, it looks like I can factor out a 3x. And then inside I'm going to have what? X plus 5. So let me come down here a little bit. And let's think about our LCD. This is canceled. Let me actually rewrite this. So x minus 3 over x plus 5 like this. And then minus, you have 5 over 3x times the quantity x plus 5. So the LCD is what? It's x plus 5. They have that in common. You just need the 3x. So this guy right here already has the LCD as its denominator. So you don't need to make any changes to that one, okay? So let me put equals here, and I'm only going to work with this one. I'm going to say this x minus 3, and let me just show this the long way so nobody gets confused, over x plus 5, and then times, what do I need to make this denominator into the LCD? I need the 3x. So 3x over 3x, and then minus, you have the 5 over the 3x times the quantity x plus 5. Let me actually wrap these to make them crystal clear what we're doing, like that. Okay, so now I have my LCD, and all I really need to do is say 3x times x is 3x squared, then minus 3x times 3 would be 9x, and then basically I'm just subtracting away this 5 here. I don't need to use brackets or anything, it's just one guy. So I'm just subtracting away the 5, and this is over my LCD, which is 3x times the quantity x plus 5. So again, you could pause the video and see if you can factor that. I'm just going to tell you in advance this is going to be prime. So this is our simplified answer. Let me make that 5 a little bit better. We're just going to have the 3x squared minus 9x minus 5 over this 3x times the quantity x plus 5. All right, let's look at problem number 10. So we have 5x plus 10 over 8x to the 4th power plus 20x cubed plus 8x squared. Then we are adding this to, we're going to have x squared plus 3x over 8x to the 5th power plus 20x to the 4th power minus 12x cubed. So in this case, it will really be to your advantage to simplify everything first before you start adding. If you don't want to do that, you can go about it that way, but it's just going to take you a lot of extra time. So what I'm going to do is just factor everything first. So this, let me copy this 5x plus 10 over, let's put the 8x to the 4th power plus 20x cubed plus 8x squared. Let me grab this real quick, and let's go ahead and paste this in here. And let's see if we can simplify this. I know from the numerator, I could factor out a 5. So that would leave me with an x plus 2 inside. From the denominator, it looks a little bit more tricky. I know I could pull out an x squared variable-wise. And then number-wise, it looks like I can pull out a 4. Right? So I can pull out a 4x squared. So 8 divided by 4 is obviously 2. X to the 4th power over x squared is x squared. Then plus 20 over 4 is 5. X cubed over x squared is x. And then plus 8 over 4 is 2. X squared over x squared is 1. Now again, you always want to see if you can further factor this. Let me write 4x squared. And then let me see if I can set this up as the product of two binomials. So 2x and x. So 2 is only 1 times 2. The 2 can't go here, but it could go here. And 1 could go here. Does that work? Yeah, 4x plus x would be 5x. So this is what I'm looking for here. Now, when we look at this guy, can anything cancel? In other words, do we have any common factors between the numerator and denominator? Yeah, have a common factor of x plus 2. So let's get rid of that. Let's remove this from here. And let's write this guy as the simplified version, which is just a 5 over. You're going to have this 4x squared times the quantity 2x plus 1. Okay, let's get rid of this. It looks a lot easier to work with. Let's go back up. And let's factor this one right here, and then I'll go back down and we'll do the problem there. From the numerator, I can pull out an x. I'm going to have an x plus 3 inside. From the denominator, I know variable-wise I can pull out an x cubed, and obviously I can cancel, but I'll do that in a moment. Number-wise, it looks like I can pull out a 4 again. And then inside of here, I'm going to have 2x squared, and then plus 5x, and then minus, this will be 3. So can I further factor this? Well, let's think about this. We have, let me put this here. So 2x and x. Let me put this 4x cubed out here. Let's see. 3 is only 1 times 3. So if I put a 3 here and a 1 here, that would be 6 minus 1, which would be 5. So put a plus here and a minus here. Yeah, that will work. So let's go ahead and slide this up here. And let's see what we can cancel. So we know that this x here, let me change color so this is clear. This x here we cancel with one of these. I could put this as a 2. And then this x plus 3 we cancel with this x plus 3. So this is completely canceled. It's just a 1. So we could write 1 over this 4x squared times the quantity 2x minus 1. So let me grab this real quick. And let's come back down here and paste this in. Remember, we are adding these two. So now my LCD will not just be the product of the two denominators because they have something in common, okay? So that trick where we just said, okay, well, this guy times this guy, that's not going to work here. So you really have to pay close attention to what you're doing. Let me actually write out what the LCD would be. So you have this 4x squared that's common to both. So you only have to list that once, okay? Then you would want to put in the 2x plus 1 that only occurs once here. And then you'd want to put in the 2x minus 1 that only occurs once here, okay? Now you could actually shortcut this thing, but you just need to remember what you're multiplying by. The 5 is only going to multiply by this 2x minus 1 because that's what the denominator is missing, okay? So you can do 5 times this quantity 2x minus 1, then plus this guy right here is missing what from the denominator? It's missing the 2x plus 1. So basically 1 times the 2x plus 1 like this. And again, you don't need the 1 there, but just for completeness. And the LCD here is going to be the 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. So you can get rid of this now. Okay, so this is pretty easy now that we did it this way. If you didn't simplify that, it would be a very, very long process to get the same answer, but you could still do it. So we'd have 5 times 2x, that's 10x, and then minus 5 times 1 is 5, and then plus 1 times anything is itself, so it's 2x plus 1. Let's go ahead and simplify. This would be 12x if I added 10x and 2x. And then negative 5 plus 1 is negative 4. So 12x minus 4 over the 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. Now, can I do anything else? In other words, can I simplify this any further? Well, yeah, actually I can. I can pull out a common factor of 4. So I can say this is 4 times the quantity 3x minus 1, like this. And this will be over, let's have our 4x squared times the quantity 2x plus 1 times the quantity 2x minus 1. Close that down. And lastly, we see that this 4 would cancel with this 4. And so my simplified answer is 3x minus 1. Don't need parentheses, it's not multiplying anything. Over, you have this x squared out in front times the quantity 2x plus 1 times the quantity 2x minus 1.